How's it going, everybody? So today we're going to cover 6.3. 6.3 focuses on the sampling distribution of the sample proportion. All right, so sampling distribution of the sample proportion. And in order for us to do that, we need to review some pieces that were covered right at the start of Chapter 3. So we want to remember that P represents the population proportion, so I'm going to call it pop proportion. And an example of this would be if we said something like 43% of people entering a store make a purchase, right? So 43% of people entering a store make a purchase. Okay, and the other important variable for us to understand is what we would call the sample proportion, and that's where I was trying to explain the notes that I have for you. The slides, they don't represent this symbol well, but basically it's P hat, or P with a caret, and that is the sample proportion. Okay. Now you might ask yourself, how does this differ from our previous discussions that we were dealing with respect to data and sampling? Basically, when you're talking about proportions, you're having there's really only two options here, right? It's that whole understanding of we're either dealing with yes or no, bald or has hair, boy or girl, okay, something like that, where there's only two possibilities. And one thing that I want to notate as well is that this is this whole concept of P plus Q equals 1, all right, where like if there's 40 boys in a room, then there's or if there's 40% boys in a room, then there has to be 60% girls, right? Something like that, okay? So that both those two pieces will always add up to 100. I just want to throw an example down here for this sample proportion. And basically what the sample proportion is it's not everybody entering a store, but it might be like out of 200 people entering a store, right? 78 make a purchase, right? And we can compare that to the population proportion as well, because we could do 78 divided by 200, and if you do that, what we're going to get is approximately 39%, okay? So remember, like the sample proportion, similar to the sample mean, no two sample proportions or sample means will ever be the same. That the thought is that they're going to be all around what that population proportion is. And you remember the simulation that we did? If you're taking, infinitely many sample means or sample, proportions, what you're going to end up getting is something like a bell curve, right? Which would bring us to the whole understanding of our, what is the name for it? I'm forgetting that right now. The empirical rule, right? And that's basically what the empirical rule says, is that, whole understanding that one standard deviation from the mean contains 68% of the data, two standard deviations from the mean contains 95% of the data, and three, 99.7. So, we have two different pieces here. We're talking about proportions, or we're just talking about data where there could be a number of different results, okay? So right now we're talking about proportions here. So key concepts that we need to understand here is, and actually, this is what I said. I just want to state it one more time. It varies. This is why I'm a math teacher, not an English teacher. From sample to sample. Okay. And we call that a random variable. Random variable, okay? Because of that. All right, so let's take a look at this key concept here. So the key concept is, and this relates to what we already did, but that the the mean of the sample proportion is going to equal the mean, all right, or the population mean, okay? And we can also say that the standard deviation of the sample proportion is going to equal the square root of P times Q divided by N. So this is similar to the previous formula that we worked off of, but a little bit different, right? And that's the entire square root of this particular thing rather than just the denominator, right? And then in the numerator in the last piece we have the standard deviation there. So the standard deviation of the sample proportion is the square root of P times Q divided by N. And what is Q again? Q happens to be the other side of things. So if there are, 80% of people have hair, then we can say 20% of people don't have hair. So the 0.180 would be the P, and the 0.2 would be the Q. So another way of doing this is an example. So a sample, could be boys or girls, it could be, any number of things, but another way is looking at binary, data, binary numbers, and you do this in coding as well, where it would be the collection of values, collection of zeros and ones, okay? Those of you who are computer programmers, all right, you can program using just zeros and ones, right? That's called binary code. And we would say that P, or your value of P is going to equal basically the number of ones, okay, divided by N. And we can say that the mean is simply going to equal all those values of ones. So all your X, we'll call them ones, but the sum of them all, you add them up and you divide by N, and that's going to give us, right? That's our sum of ones divided by N. And we can say that the sample proportion which is going to equal the sample mean. So yeah, we're doing two different types of problems, but essentially what we are doing is, we're relating it to a similar type of thing. So this, so now what we're going to do is we're going to take a look at, for large samples of proportion, right? We want to say that it's approximately normal. So this is what we were talking about before in the earlier section 6.1.6.2. This is a key piece for larger samples. So remember, in that simulation, as our samples got larger and larger and larger, right? As our samples got larger and larger and larger, we started to see that there was in fact a bell curve shaped graph that was occurring here. So for larger samples, the sample proportion is approximately normal, okay, with the mean sample proportion, right, or P equaling P, and the standard deviation of the sample proportion equaling the square root of PQ over N, okay? So, these are those formulas. So, in other words, right, we have a sample is large if the interval, okay, so this is important key concept here, right? we take P and we subtract from it 3 times the standard deviation of the sample proportion, right? This is more what we're doing with when we were talking about the empirical rule, okay? But that if we subtract three times the standard deviation, right? And we also add 3 times the standard deviation, okay, of that sample proportion, if it will lie, it's going to lie within the interval 0 to 1, okay? So all that's saying here is that when you add these two values together, right, we know that it adds up to 1, but if you were to subtract or add 3 standard deviations from P that it's going to be within there, it's essentially going to be a percentage. It's not going to be less than 1, and it's not going to be greater than 1, okay? And, you know, one other thing for you to know is that where, you know, P is not known, we would sub in the sample proportion. Okay, so sub in the sample proportion when P is not known. Okay, so, you know, this is something that we're going to work on and we're going to expand on as we work in Chapter 7. But one thing I do want you to understand, and I'm going to end this video, that we are going to continue to kind of toggle between these two types of problems. So we talked about sample proportion, but we also talk about sample mean. And I want to flip to another page here just so you understand that. But there's really two types of statistical analysis that we are going to work out. We are going to talk about, you know, sample means, and we're also going to talk about sample proportions. And you remember the sample proportion is when we are dealing with P's and Q's, right? P plus Q equals 1. Where the sample mean, there's more than just 2 answers here. There's more than just P and Q. You know, there's other possibilities, other results. Taking temperatures of people could be infinitely many responses, right? Where P and Q, it's like, okay, all we're dealing with is, you know, yes or no, right? Okay, so we're going to be dealing with a lot of different problems that are going to work in these two different ways, and then there's these two similar but different ways of evaluating the sample mean and the sample proportion. But one thing for you to know is that the sample mean and the sample proportion are always going to be approximately normal, meaning a bell curve that has these properties, right? 1 standard deviation from the mean, 68%. 2 standard deviations from the mean, here to here, right, is going to be 95%. And 3 standard deviations from the mean is going to be 99.7%. Okay, so that's that for the end of 6. It's kind of bringing it all together. And I'm going to introduce Chapter 7 next. All right.